Well, welcome back to this exciting edition of Voices of Video. So, I am joined today by two companies that don't really need any introduction. Chris Milsted from Akamai. Welcome, Chris.
Thank you very much, Mark. Hi, everyone. Love his beer.
Yeah. Awesome. And Dennis, it's great to have you back. Dennis Mungai from Cires21. Welcome.
Thank you.
We, of course, had a nice interview leading up to NAB. Dennis and I did. We talked about everything that Cires21 is doing. So today we came together to talk about some recent benchmarking and a study that both companies have worked on, Akamai and Cires21. Chris, why don't you give us a quick overview of what this study was comprised of and what you did?
Yeah, thank you very much, Mark. The study was really trying to get a different angle, a different look at kind of the traditional benchmarking and kind of approach that people take to transcoding and encoding, and people tend to look at, just basically raw power. What I was really interested about, and what we've had a number of companies kind of contact us about, is what are the other aspects they can look at. And one of the really hot ones at the moment is energy efficiency. And what we were interested in and what we're being asked about is, I know there's some kind of political, tides maybe against some of this green reporting and stuff as was maybe a couple of years ago, but companies are still interested in their scope 3 emissions and like how actually energy efficient and how actually, bearing in mind all this Gen AI stuff that's going on and sucking all the electricity out. And we're starting to see, 6 gigawatt at campuses involved being projected by some of these big hyperscalers. How do we actually get better energy efficiency, and how do we actually get more, bang for our kilowatt when we're actually doing all these work and transcoding video?
Mm-hmm. Yeah. Energy efficiency, I know you're in Europe. Dennis, is working in Europe and other parts of the world as well through Cires21. There is no doubt that whether it's through which rightfully so, we still need to care about carbon emissions. So, it is true that, there's a little bit of an ebb and a flow in terms of the focus on, net zero by 30 and those sorts of initiatives. But, the environment does matter. I don't think anybody would disagree with that. But the other side of that is just the cost and the fact that in many countries or regions in Europe, you simply can't build data centers. Like in the Netherlands, from what I understand, talking to people who are running data centers in the Netherlands, you can't build one. So if you need to increase capacity, you either need to find a more efficient way, to get that computing done, or you just simply can't grow, which is not good.
Yeah, exactly that. And I think, whether it's to do with the reduction in carbon emissions, you might have a fixed power budget for your data center.
That's right.
And if you need to do transcoding, you might have to sacrifice, some other capacity. You might not be able to replace, a high-powered GPU with an even higher powered GPU to do this work. So what are your other options, and what choices do you have in the market? So that was really the idea behind the study and the investigation.
That was the idea. Yeah, that's great. Well, Dennis, Cires21, I know, played a real pivotal role in supporting Akamai, working with Akamai. Of course, this is what you guys do, is run video workflows. So how did you support Akamai in this process? And then, and then let's get into what actually did you study and how did you approach the study? And
Approach we used with Akamai was default. First of all, provide the reference software stack that we can run the production grade benchmarks on. using flows that are similar or mirror our encoding settings. The second and the third way was on collecting the necessary metrics and comparisons between the respective platforms. That is for the NVIDIA GPU and for the NETINT card that's installed on one of their appliances. And then the third way was also just analyzing the results in detail and also making sure that any edge cases we ran into are clarified through either repeated tests or
Mm.
a further reanalysis of the same.
Mm.
Yes.
What software were you using? Cires21 media processing framework, or were you using something a little bit more generic, one of the open source, or what were you
We have
operating
tested
this on?
some of these workflows with both Cires21's implementation and also for the reference pipelines, a bit of FFmpeg's libx coder integration. Yes.
So I guess you answered the question, but I just want to make sure it's clear even for the listeners. So were these, I'll call them encoder level evaluations, or were you really attempting to emulate, like, here's what the power consumption and of an end-to-end workflow would look like? How did you approach that?
Our approach is actually taken from a very common workflow type we see, whereby you will want to take a very high resolution content. And specifically, I mentioned the samples we used. We used Netflix's Meridian Film, which is a common benchmark for VMAF scoring and transcoder benchmark evaluation. And then taking that source, you downscale the content into various resolution ladders, and then you measure the maximum simultaneous ladders you can run per job, per resolution, per frame rate, until you saturate the respective GPU slash VPU to the point where you no longer have real-time playback. And the main focus here is that we consider a transcode successful if you can maintain at or above real-time playback, because the target scenario here was also set to around 60 FPS, which is very common for sports and other live broadcasting scenarios. So that even if you have lower frame rates on any of the ladders, you can then extrapolate based on the available data the kind of density you can run on each implementation side by side.
Excellent.
Yes.
Okay, great. So Chris, I'm not going to assume that all of our listeners know how Akamai is supporting VPUs. Maybe it would be helpful to back up and even just explain the architecture and the topology.
Yeah, sure. I think just a little bit of a background. So about 3 years ago now, Akamai acquired a company called Linode. So they were a kind of a cloud provider, one of the kind of mid-tier ones, I guess, to begin with.
Mm-hmm.
And I think what we looked at internally was actually, what were we spending on our cloud computing budget? So, I think it's a story we've told as well within Akamai that we've saved, a very large amount of money by moving a lot of our services in-house. And one of the other reasons we're doing that is we thought, well, we have this cloud computing platform. We should start at offering services on there and building on that Linode platform. So what we're doing now is, you've seen a couple of years of as that Linode acquisition has happened, we brought that onto the Akamai backbone. So you're seeing the full power of the Akamai network. Mm-hmm. So, our content distribution network and our global reach in there. And now we're starting to build kind of these specialist services on top of that. And we've got this great partnership with NETINT. So the NETINT cards, they're fantastic. They just fit into the PCI slots in the front of your servers. So literally, we've got a bunch of servers in a bunch of data centers, all the cards, and then we basically work to offer plans that customers can just, by the hour, come along and consume. We put out some initial plans. That's one thing I would say. So there's some initial kind of T-shirt sizes with the NETINT cards with, various amounts of CPU, RAM, and number of cards. I think for anyone who is interested, I think we're still exploring, exactly which data centers to next launch additional services in. And also we're open to feedback on exactly what those t-shirt sizes would be more desirable in the future. I think they're very nice to kind of cookie cutter out. But if there's other components that people want to do and kind of combine the NETINT cards and the CPU, we are getting some feedback that maybe we need to be a bit more flexible there. So, if anyone is interested, please get in touch and give us some feedback on that.
Yeah, it's great. We really appreciate our partnership with Akamai, and we're seeing tremendous interest from our side. For several years, kind of the number one question that we got, and this was before we installed, a lot of VPUs in the Akamai network in Linode. The number one question was, what cloud are you on? Because it is absolutely true that many platforms are looking to move off kind of the usual suspects, shall we say. But at the same time, they're not necessarily wanting to go out and take on certainly building a data center, but even maybe taking on the management of a colo, so they're looking for that like infrastructure as a service. And I think that is so valuable, in the industry, I believe, is responding very positively to Akamai's offer. So I want to get back to, some of the findings of the study, and, I'll let one of you jump in, or both, to talk about this 4.7x, if I'm recalling correctly, power efficiency, I guess, advantage of VPU over GPU. Anytime you see a big number that is really impressive, I think it's natural to have one or two responses, oh, wow, tell me more, or, sort of eyebrows raised, like, how can it be? That sounds a little too good to be true. So what can you, tell us about this 4.7x advantage? What does it actually mean? Just explain that.
Do you want me to have a go at that, Dennis, and then you jump in if I get anything muddled up?
Absolutely, that we can do. So our observations here, and this is the part where we say sometimes apples to oranges can be a bit misleading, is due to context. What we observe with the NETINT cards is that you can run the same workload density to a degree, not to a fault, but to a degree, as you would on the NVIDIA cards for a fraction of the cost and with near matching VMAF scores, even for the most recent codec types, specifically AV1 and HEVC. And yes, the power difference that we observe between the NVIDIA and the NETINT cards is actually correct. This is something we have run about a couple tens of times just to be sure. So that claim holds.
That's amazing.
That claim holds. Yeah.
And I'm glad you referenced AV1 and HEVC, because, anytime we're talking about encoder studies, that's a very natural question. Well, which codecs did you use? And which implementations? And also, just to be clear, and by the way, we'll link up to this study so that people can download the paper, go to the blog post, etc., in the show notes. But correct me if I'm wrong. It was the RTX 4000 GPU, right? That was benchmarked.
The RTX 4080, the Ada generation. Yeah.
Okay. And that's also important, because, then the next natural question is, well, which GPU did you compare with? And also what's important is that is a GPU that also is available in Linode. and for certain applications would be an excellent choice. So one of the things, we're all engineers here. I'm the least technical from the two of you,
Sure.
but I am a technical person, and so I always appreciate, and even in marketing, we're always, I tell my team, and I think to myself, like, okay, let's get to the ground truth. Let's make sure that we're not just sort of talking and hand waving. And so I like the fact that you benchmarked on the same platform. There's no tricks here. It's not like, running a GPU in some different environment. And then, it's on Linode. There are instances that are available. Somebody could go out and replicate this study if they just want to prove it for themselves. Remind me again, what video set did you use?
Specifically, Netflix Meridian Film. It's
That's right.
part of
That's right.
their open content platform where
That's
video
right.
engineers can take samples and then use it for analyzing video pipeline flows for performance and conformance.
That's right. And the objective metrics was VMAF. Did you also use PSNR or even SSIM?
To an extent, our main focus was on initially VMAF, but you would be pleased to know that as far as PSNR is confirmed, the results also hold.
Yeah, that's great.
Yes.
Yeah, that's great. And so I'm, what I'm pointing out here again for the listeners, for some of our maybe slightly more skeptical engineers, which, we do primarily, our audience are engineers or engineering, oriented. This was done, this is a proper study. So I think that, you will find if you go do your own independent analysis that these results hold. And there's not going to be some wild variance, which we've all been a part of those, right? Where you go fact check something, you're like, how come my numbers are so much different than what, this company is claiming? So,
and I'll say that for Dennis as well. So we did repeat, with kind of gaps in the testing and stuff.
Yeah.
So, the cloud instances we spun up were returned to the pool. So we definitely got different machines each times. And I saw with my own eyes over and over and over again, at the very heavy workloads, the NVIDIA cards would peak in the low 80 watts. I think I saw maybe 12 watts as a maximum for the VPUs. And I saw that over and over and over again. There was no real variance. I mean, those numbers were pretty solid time after time after time.
So I have, just because my memory isn't what it used to be, so I wrote some of these numbers down. And of course, you're much more familiar with them since you guys were, ran all this and compiled the data. But yeah, so 1080p 60. The VPU, so NETINT VPU, was able to run 19 jobs at 12 watts. The GPU ran 16 jobs, so a little bit less, but at 59 watts. So it's pretty significant. Yeah, it's amazing. So, I think, we can really dig into the numbers. And again, I would just encourage everybody to, go download the paper, read the blog post, and even if you want, replicate some of this yourself, go study it yourself. But I'm curious for each of you, and I want both of you to answer this from your respective positions. So Chris, from the Akamai perspective, what surprises were there for you, in running this study? And then Dennis, then you can answer next from the Cires21. But Chris, what were any surprises? Was there anything that you're like, whoa, I didn't
I mean, I think the massive surprise was just how low the power started and how low the power stayed. And I think, that really demonstrated, we seem to be going full circle now we're back to designing custom silicon and
Isn't
the
that
engineering
interesting?
silicon.
I'm glad you point that out, because 20
And
years ago, that's all we had was custom silicon, and then nobody wanted it. And now here
yeah,
we are. Yeah.
and we're going there. And it's amazing when you look at, quite the energy efficiency you can gain with that. And I think, we also ran some other numbers around, what would be the cost per stream as well. And those are good numbers as well, depending on your resolution. So I was just like blown away and said, well, actually, this is kind of a no-brainer for these, these AV1 HVC workloads.
Yeah.
If you've got the right workload, then this is just by far the best way to do. And also, when you think about the emissions and the density and how you could get these into a data center, I mean, we're talking about people who want to put something like, I think they're talking about megawatt racks or something absolutely insane in the future. And I'm looking at that going, this is far more sensible, air cooled, much more sensible way to go. So I think it really just made me stop and think and reevaluate kind of number of design decisions and just kind of play that off against, kind of the AI market, what they're doing, and thinking, there's got to be a better way to do things. So that was my kind of main original. And, I love the fact that they're available in the Akamai cloud, and, buy them by the hour if you need them, or as long as you want. And that's the nice thing about that consumption-based computing as well.
Yeah. By the way, starting at 42 cents an hour for the, like you say, there's t-shirt sizes. So that's the current, I think that's the small instance.
Yeah.
But I mean, it's just, yeah, the economics are incredible. So Dennis, what surprises for you?
My initial surprise especially came around with, I would say, the NETINT stuff first, because out of bias, I tested it last. And I did this specifically because I was trying to see how a card of this form factor and power draw would match to a flagship. And what we noticed is that perhaps due to the fabric or the nature of its design, its level of parallelism as far as simultaneous real-time jobs are concerned is a very, very consistent number. That number doesn't dip, it doesn't clip. Whereas with NVIDIA, despite having a lot of these GPU resources, the main limiting factor are its NVENC engines. You basically cannot offload a lot of these video processing past NVENC. NVENC is what will handle the encoding and the output of the bitstream. Sure, you can offload scaling and everything else to the GPU, but at the end, the primary bottleneck is the number of NVENC engines you can have in a GPU like this. And that limit will hit you hard where you least expect it. Because the expectation here would be that the NVIDIA GPU would naturally fly through the workload, but it doesn't mirror expectations.
Yeah.
Especially at the resolutions we tested at.
Yeah.
Yes.
Yeah, we so thank you for pointing that out. There actually was some incredibly intentional, as you would expect, design behind how the ASIC scales in terms of the number of threads or jobs that are happening. Obviously, an ASIC is a different architecture. It's not correct to talk about like CPU cores, which, a GPU, you kind of can think of it that way in terms of just a tremendously high density of compute cores. But there is the notion of threads. And one of the beautiful things about the way the Quadra is designed is that it scales. So this is something that everybody has to sort of first wrap their head around. We're all used to in software. If we're running, let's say X264, you're going to get the highest density, obviously, because it's not as compute intensive of a codec. That everybody knows that. Then you go to X265 HEVC. Fortunately, X265 has many, many, many years of the open source community optimizing it, and so it's now maybe only 2x or 3x more compute intensive than X264, which really, when you consider the benefits of HEVC, is really not bad. In fact, it's actually pretty amazing. But then you go to AV1 and I mean, it's, oh my gosh, it's 10x, the compute requirement, even, with SVT AV1, obviously depending on the presets and the speed and a whole lot of factors, right? But the point is that inside an ASIC, you don't get any both hit or benefit, if you're encoding H.264, HEVC, or AV1, which means you're completely predictable. You're able to plan your capacity, plan your throughputs. You don't have to worry about the encoder falling down because, my top profile, actually I have, I'm choosing to encode that at AV1, with AV1, and I've got a couple at HEVC, and then the rest are H.264. It's completely predictable, and it scales on resolution. So a 1T1U will do 32 1080p 30 streams. You say, well, what would it do for 4K? You literally just divide by 4. It's 8. But a GPU doesn't quite scale, and a CPU, forget about it. You definitely don't just divide by, you have to go test it. And, you might find, you have to divide by, some higher number. So it's a real benefit, to both the ASIC architecture and then the way that Quadra was designed. Yeah. Well, I think, what would be interesting is to talk about, studies are great, and data is important, and data helps validate, technical decisions, and obviously, Chris, for Akamai, data is very important because you have customers coming and saying, "Hey, we've heard about these things, but show us that the claims are real," and so you need that. But I'm curious, what someone could do with this data. Like, what does it mean? Because numbers are awesome. Wow, 4.7 X energy advantage if I switch to VPUs. On one level, you're like, well, of course, what it means is, they're going to save money. They're going to, not be polluting the environment with as much CO2, et cetera. But what does it really mean? And Dennis, maybe you're in a good position to comment on this. And then Chris, I'll let you give your perspective. Because Dennis, you've been building software for many years. Cires21 has. And so when you have a tool like a VPU, how is it changing the way that you're building systems, the way maybe customers are thinking about, what you're building, their requests, what does it mean?
For us specifically, it has brought about possibly the fastest turnaround time between prototyping something in R&D and having it in prod. And this is because the whole VPU stack is very simple. You only deal with a single fabric, which is NVMe. You want to query the status of the device, it's NVMe. It's a very simple, plain NVMe namespace. So that even when you port this to something like a containerized instance, provided the NVMe namespace is available, regardless of the privilege level you're running at, you will have the encoder sessions in those instances. And then the second part here is also the function of resource abstraction. You view an NVMe namespace as if it were a single object. So regardless of the number of VPUs you've passed to a given container, you will still be able to independently allocate jobs to them without affecting the specific runtime affecting what's happening on one VPU versus another. And this also stretches towards what you would call resource monitoring and allocation. This is for when you need jobs to fail over from an available VPU to another, regardless of how the VPU instance was instantiated, be it on a cloud or on premise. provided the namespace is valid, you're going to have a libx coder session. And this is the kind of, it's a level of certainty that does move some design decisions forward and at a much faster pace than we would have anticipated. So a bit of context here, just to step out a bit from what you're talking about. For you to evaluate a GPU-based encoder, depending on the various models you have out here, and this also goes beyond outside NVIDIA, you're going to have to, first of all, separate the kind of environment you're on, because bare metal does not translate to the same thing as an MIG instance, even when it simulates bare metal. But a VPU is a VPU. It's a single/dev NVMe. And as long as that namespace is available, regardless of how it was started up, you have that level of persistence in that deployment time that you asked for. So for us, in terms of design decisions, you move faster, but without breaking cadence. With GPUs, you will need to not only prepare extra layers for provisioning with a lot of safety checks, but you also have to be aware that some of the pipelines that you deploy for tests in R&D will not be one-to-one mirrors in production. So with VPUs, we have moved the gap between certainty and predictability to certainty with speed.
Yeah.
Yes.
Yeah, I really like that you're pointing out certainty.
Yes.
I think for anybody who's operating, even if it's a small video service or platform, certainty is above all else what we want and need. Yes, you want it to look good. Yes, there's a lot of other factors, but you want to know that the system is going to behave and operate the way that you predict it to, the way it should, designed it to, not predict. So yeah, that's really great. Yeah.
Yeah. And just to echo on the back of that, I mean, I think me and Dennis jumped on a WebEx or something when we were first agreeing to do this. And I think after we'd found out, which lab he was trying to dial in from to the machines, I think 3 minutes after I clicked the button, it's like, there you go, they're ready to go. Off, let's get the pipeline on there and off we go. I just that kind of fungibility around the cloud computing, cloud resources, I think that should add to the mix as well.
Yeah, and I think what's also important to point out is there still is the walls coming down on this belief, but there still is a little bit of a belief of, okay, I hear you, ASICs are more efficient. I've seen the quality, or I've heard from colleagues the quality is good, but it's hardware. It's not flexible. It's sort of that feeling of like hardware is like hardened, and yeah, if you own a data center, great, use hardware, put it in your data center, and what you guys are pointing out in these, in your observations is that actually it's very VM and container friendly. And it's engineered for that, in fact, and it's engineered to scale and all those things. So some of the mindsets can actually shift. Not that the mindsets were wrong, because other hardware that isn't built around NVMe, as you pointed out, Dennis, it's one of the major advantages. Our engineering team really struck gold when, they literally just went, well, why don't we just use the NVMe interface? Not every machine, but nowadays, every modern machine supports it. We plug the card in, whether that's through a PCIe electrical or mechanical interface, or through a U.2, or even now the new M.2, which we have a card coming out on a super, super small M.2 form factor. And it works. It's available. All the resources are there. There's no drivers. There's no OS compatibility. All of those things which other hardware really struggles with, including GPUs a lot of times. So yeah, it's very interesting. Well, good. Well, This has been a great discussion. Thank you for sharing. I'd be slightly remiss if I didn't, say, hey, what's coming? I'll try and avoid the, what's in the future. Are you tracking? But seriously,
Well, I think with IBC coming up, if we say anything ahead of IBC, we will be shot. So we'll keep that quiet for the show, I think.
So I'm certainly not looking for any pre-announcements from Akamai. Absolutely not. I like you, Chris. I want you to keep your job. So um, but from I want to phrase the question, and I would love to get your thoughts around how systems are being built. We went from the era. It is interesting. You point out, Chris, 20 years ago, the original MPEG-2 encoders were silicon because that was the only way to do it. MPEG-2, it was silicon, right? Dedicated ASICs. And then we went, through this period of everything was CPU. And then the, GPUs, started to, kind of catch on a bit. And now with NETINT and we really are welcoming others, who are saying, hey, there's an opportunity here to build very, very high quality silicon, that is flexible, that's performant, that is high quality, that can bring a lot of advantages. And so what does this mean for how we're going to be building our video platforms, in the future? What are your perspectives?
Well, I think from the Akamai point of view, I think what we're looking at is how do we bring these devices closer to where they're needed? So we talked about the live streams and you talked about sport. I think at the moment, when you look at the Akamai kind of cloud, we have these kind of distinctions internally where we have these kind of core sites where we're building out with, all the kind of the object storage and all the kind of other core components you'd expect. But of course, those are big investments. So they're going to be in a limited number of facilities because you're going to need a lot of energy density in them. You're going to need a lot of power and cooling. So then we've got these other models where we've got down to our content distribution network and a kind of our edge sites. And in between, we're looking at kind of this hybrid model, kind of distributed site, which is kind of how do we, for example, if you've got a live sports feed that's from a country that doesn't have one of these very large data centers, could we actually bring these netting cards closer to where you'd want to be streaming that live feed? And then looking at kind of technologies, everyone's been using satellite to distribute those feeds as they go around traditionally. Well, we have the Akamai backbone. How could we start looking at maybe we could pipe this over that as well? So I think from the Akamai side, we're looking at more, rather than taking kind of the data to a site, we're looking at how do we kind of take the capabilities closer to the end users and where they're actually needed. I think that's kind of our main focus at the moment. And I'll hand over to Dennis on the kind of encoding side and observations there.
So Dennis, what does having really highly performant VPUs, hardware in the network, what does that mean for you in terms of how video systems are being built, or what do you see? Is there some major shift or trend, or does it open up possibilities, or is it just about cost savings, which is fair enough? Could be just like it's business as usual architecturally, and we're just going to be able to deliver video at a much lower cost. What do you see?
I have never viewed cost savings as the goal. Cost savings is a side effect of well-designed systems. And I believe the goal here is how to call not just togetherness, but separating the distance between iteration to prod. Bringing systems this closer not only shortens the product lifecycle gap, but it means that with potential firmware updates, especially for the VPUs, you not only get newer codec support down the line, but you also get better rate control methods for the various encoding schemes you have. So essentially, you get like a hardware fabric that behaves like a flexible software fabric. Small, incremental, and meaningful upgrades only when they're needed. And if they are not needed, you can have these rolled out in separable revisions such that regardless of the distance or deployment type you have, we never have to constantly break production with dependencies we do not need at the encoding layer. A simple example here being how the NETINT VPUs work. All you have is an NVMe device, and there is typically no quote unquote host side driver. All contexts are initialized through libxcoder, and then from libxcoder, you then birth, or should I say, create a single namespace from which you can then derive multiple encoder instances depending on resource availability and scaling. So this kind of compactness also allows us to reduce the kind of resources needed to push the same workload. I'll give you a simple example from production we have. We have had containers as small as sub 100 MBs in size. And then compare this to something that needs a whole CUDA stack to build. When you're pulling down the CUDA stacks from the NGC, that's going to be about 3 point something gigabytes in size versus 100 megabytes for the same appliance, for the same instance, for the same deployment type. So not only are you improving iteration times, but you're also improving deployment scenarios for places that may be so remote, you may not have the bandwidth you assume a lab facility has. So for us, the kind of work that NETINT is doing, where you can move a lot of this stuff to the edge if you need to and keep them on cloud as needed, is a level of flexibility you appreciate. I think this is the part that we will have to essentially learn how to live with and also pay for with time, because the real, like I said, the cost savings is not the goal. It is the outcome of systems so well designed that it becomes an inevitability. Yes.
Yeah, it's great, incredible insights, and we totally agree with you. It's interesting just to circle back around on the environmental aspect of reducing your hardware footprint. I've been in many conversations where, sort of behind closed doors, people were forced to kind of admit and say, look, at the end of the day, we're going to end up buying whatever's lowest cost, first, and my response is always, well, that's great news, because when you're able to, get a 4x, a 5x, a 6x, or 10x density advantage, it's lower cost, you're consuming less energy, and guess what? You're not polluting the environment with as much CO2 because you're consuming less energy. So it's fascinating how, when you are focused on doing things, when we collectively, the industry is focused on really driving efficiencies through every step of the end-to-end workflow, it has residual effects. Our operational costs generally are reduced. We're using less energy, et cetera, et cetera. And so those are all good things. So it's wonderful. All right. Well, Chris, Dennis, thank you again for joining me on Voices of Video. I look forward to seeing you both at IBC in Amsterdam, just like five and a half weeks away now. So it's coming up soon. It'll be a great time. And if any of our listeners are going to be in Amsterdam at IBC, make sure you stop by the booth. Say hi. Dennis, Cires21 actually has a stand in the VPU ecosystem. So does Akamai. So Akamai is going to be there, and I'm sure Chris will be hanging out and in and out and all around. So so this is going to be really good. Great opportunity. So again, thank you for listening to Voices of Video. We appreciate you all, and as I always say, happy encoding.